All right, welcome everybody. This is Unit 5, Graphing Quadratics. So the first thing we're going to talk about is some vocabulary. We're going to talk about the key features of parabolas. And parabola is like the shape of a quadratic. In like linear equations, if we had a graph, it'd be something like this with a straight line. For quadratics, it makes this parabola shape. All right, so we're going to talk about these key features. Here I already have them filled in just for the sake of time for our video, but you're welcome to pause anytime to like jot that down, okay? So first off, we're going to talk about the y-intercepts. Okay, the y-intercept is where the parabola crosses the y-axis. Just like when you had linear equations, and if we had this linear equation that crosses the y-axis, that would be our y-intercept. So it's similar what you did with linear equations. All right, so it's just where the line or the parabola crosses the y-intercept. We also have x-intercepts as well. In like when we had linear problems, it would only cross the x-axis one time. Okay, for quadratics, you can get two x-intercepts. Those x-intercepts, those are the solutions of your equations. All right, so if this is the equation for this particular graph, if we were to wanting to solve this, okay, if we want to solve, we set y equal to 0 and we solve, so this would give us our solutions if we do this. Okay, you could do any method that you'd want. We talked about 4 different ways that we could solve. I'm going to do factoring, so we'd get negative 3x squared and would need to add up to give us a negative 2x. So perhaps something like negative 3x plus 1x would make that work. Since a is 1, we can write our solutions really quickly. We'd use the shortcut. We'd do x minus 3 and x plus 1. If you don't remember how to factor and solve using factoring, you may want to refer to previous videos. Okay, and then again we'd use like the zero product property, which means if we're multiplying two things and it gives us a 0, then either A has to be 0 or B has to be 0. So either x minus 3 has got to be 0 or x plus 1 has got to be 0. And then we'd end up getting our solutions. Would solve for x, we'd get x equals 3 and a negative 1. Okay, so if we look at this graph, we can see where the parabola crosses the x-axis at negative 1 and at 3. Okay, so you'll see different parabolas in different situations. Okay, you could have a parabola that only crosses the x-axis one time. All right, you could also have a parabola that never crosses the x-axis. Okay, so again, this is where we have like one solution, and here we would have, I guess not really pointing to that point, but we would have two imaginary solutions, okay? And we'll be doing lots of graphing quadratics, and you'll see a lot of situations of all 3 times, where it crosses the x-axis 2 times, or just 1 time, or it never crosses the x-axis, and we'd have imaginary solutions, all right? Okay, axis of symmetry, or here it's called the line of symmetry, and both are good. Okay, the line of symmetry is where is a line, okay, where it crosses, where it cuts it into exactly into 2 parts. Okay, it's symmetric, right? So a vertical line that goes through the vertex, and it cuts it into 2 equal parts. Okay, I guess we haven't really talked about the vertex yet, but here's the vertex. Okay, it's where, it's like the inflection point or the turning point of the parabola On the left side, the slope is going down. Here, the slope is going up. So it's here at this point at the vertex, the slope here would be 0. It's between the negative slope and the positive slope. Okay. All right, so that's all in here. Again, the y-intercept is where it crosses the y-axis. The x-intercept is where the points where the graph crosses the x-axis. Okay, and again, x-intercepts are the solutions, and if it doesn't cross, if there are no x-intercepts, then we'd have imaginary solutions. The axis of symmetry is a vertical line that cuts the parabola exactly in half, and it's symmetric, thus the axis of symmetry. Okay, vertex is the point where the parabola changes direction. Okay, so like when the slope changes to positive to negative or negative to positive. All right, and then we're also going to talk about if the vertex is a maximum or a minimum. Okay, so we would just look at the vertex and say, is that the minimum point of the parabola or is it the maximum point? So here for this example, this would be the minimum, and its value here would be a negative 4. All right, and then the direction of opening. So if it's going up, like if these arrows are going up, if it kind of makes a happy face, then it's opening up. If it's going down like this one, this would be opening down. All right, so let's answer some of these examples. So the y-intercept here, we would want to write that down. Okay, in the past, maybe you said the y-intercept would be a -3, but we'll be writing everything in ordered pairs. So the y-intercept here would be 0 in the x direction and -3 in the y direction. Okay, just remember ordered pairs are always x comma y. So we'd want to do the x first and then the y. It's just like alphabetical. Okay, the x-intercepts here would be -1 in the x direction. This is the one I'm looking at right now. -1 comma 0. And then the second x-intercept would be 3 comma 0. Axis of symmetry. So the axis of symmetry is a line. So we'd need to write it as like an equation. It's always going to be x equals, okay, and whatever it crosses the x-axis is 1. So here the axis of symmetry would be x equals 1. Okay? It's a vertical line. It's always going to be a vertical line, and its slope will be undefined. Okay, vertex, again, we're going to write down this point. Here, the x direction is 1, and the y direction would be -4. Okay, we already talked about this. Is the vertex a maximum or a minimum? Here it is a min, and its value would be a -4. And the direction of opening here, since it's a happy parabola, like this, it's going to be up. Okay, you're filling up. Okay, happy parabola is concave up. All right, so let's do some examples. Feel free to, we can do this one together and then maybe pause for some of them to make sure you feel like you're understanding. Okay, so we'll look at this parabola and we want to identify these key features. So first off is the x-intercept, where it crosses the x-axis. So we have 2 in this situation. One would be -2 comma 0, and then the other would be 4 comma 0. The y-intercept, which is right here, would be 0 comma 8. Axis of symmetry, okay, it's the vertical line that cuts the parabola in half. Okay, so that would be x equals 1. Okay, so for all x values, for all y values, x is 1. So vertex here would be 1 comma 9. Is the vertex a maximum or a minimum? Here we have a max, and what's its value would be 9. And the direction of opening, in this situation, it's down. Okay, it's a sad parabola. All right, so give these two a try. See if you can do these by yourself. All right, so here our x-intercepts are here and here. So we have -4, 0 and 2, 0. Our y-intercept is 0, -4. Axis of symmetry, the vertical line that cuts the parabola in half, so it'd be x is equal to -1. The vertex, okay, here we're just going to have to estimate. Looks like in the x direction it's -1, and then the y direction it looks like maybe -4.5. Is the vertex a maximum or a minimum? It is a minimum. What is its value? Would be a -4.5. And the direction of opening is up. Okay. Here is another example. Hopefully you gave this one a try. X-intercepts, here there are none. That means we have imaginary solutions. The y-intercepts will always have a y-intercept. Here it looks like it is 0, -2.5. Axis of symmetry, what cuts it in half would be x equals a -1. The vertex is this point, would be -1, -2. It is a maximum of a value of -2, and it opens down. All right, so we talked about all of these key features. We're also going to be talking about intervals. Okay, so things like domain, range, increasing, and decreasing. So the domain is all possible x values. Okay, if we look at this example above, as we go in this direction, okay, this just continues to go forever. Okay, so it just keeps going in the negative x direction, and then on the other side, this continues to go in this direction forever, okay? So we can write this in two different ways. We can write it as interval notation and inequality notation, okay? So if we're going to use interval notation, we'll be using things like parentheses or brackets, and we'll talk about when we use which. So in this situation, it would start, all x values start, which I guess never start, but starts at -infinity, because it goes forever in that negative direction, and goes all the way to infinity. Okay, if we were to use inequalities, we would write it like this. -infinity is less than x is less than infinity. So x is somewhere between -infinity and infinity. Okay? When every point, every value is part of the interval, we also write this as all real numbers. Okay, and we've talked about real numbers before, and that's what we would call it, as this fancy R. Okay, let's talk about range. So range is all y values. Okay, so how are we going to look at this? And we're going to say, well, this parabola keeps going down forever. Okay, it never stops. But as we go up, it doesn't go any higher than -2. Okay, so our interval here would start at -infinity and would go all the way up until you get -2. Okay, and we will do a bracket at this point because that includes the value. If we look at this point, the parabola includes -2. Okay, we didn't use brackets for infinities because infinity isn't a number. It never reaches a single point, if that makes sense. All right, if we wanted to write this with inequality notation, we would say it's all y values less than -2, or less than or equal to. So y is less than or equal to 2. All right. Okay? Increasing and decreasing. So when we're talking about increasing and decreasing, we're talking about like the slope, okay, or the rate of change. So we'd want to say, well, where is the parabola increasing? Where is the positive slope or the positive rate of change? Okay? So if you were, and we always will kind of go left to right. So if I was like walking on this parabola, I would be going up the parabola. Okay, it'd be positive slope. Okay, so this would be increasing. All right, so increasing would start, again, we would start way over here at negative infinity and would stop until you got to this, the axis of symmetry, which would be a -1. Here we do not include -1 because the slope at the vertex is 0. It wouldn't be increasing or decreasing. If we used inequality notation, we'd say all x values less than -1. Okay? And then for decreasing, if we were here at this point, walking would be going down the parabola. It'd be decreasing. The values would be decreasing. So we would say it's all x values starting at -1, but not including -1, all the way to infinity. And again, we could write it as inequalities as all x values greater than -1. Okay, so note that all of these intervals, except the range, are done according to the x-axis. Okay, so if we look at all of these, especially if you're like looking at the inequalities, all of them are using x's except for the range. So you can kind of keep that in mind when you try and do that. Okay, and like, sorry, I probably should have mentioned this. So inequalities are things like less than or equal to, greater than or equal to. Okay, so we'll use those kind of symbols to do inequality notation. All right, so you may want to pause or think about this, fill in any of these spots that you'd like. Okay, let's do some examples. All right, so here we go. If we want to find the domain, again, it's all real numbers. And for here, we could just write it like this, okay? Perhaps on your homework or on a review or on a test, you may be asked to do it in both or either of the forms. So for these, I'll write that in both ways, okay? So for the domain, we could write it also as -infinity to infinity, or we could also write it as -infinity less than x less than infinity, okay? Range, for this situation, we start at the bottom. This is its lowest value, and it keeps going up to infinity. So we'd say something like it goes from -4.5 all the way to infinity. Again, we'd use a bracket for range because that point is included. You could also write it as all y values greater than or equal to -4.5. Where is it increasing? Okay, well, it looks like it's increasing here. So that would give us all starting at -1 to infinity. Or we could write it as inequality, so all x values greater than -1. And then decreasing would be everything else. So it would go from -infinity to -1. And all x values less than -1. All right. Okay, if you'd like to pause and give example 3 and 5, I guess I kind of skipped 4. All right, so if we look at this example, our domain here would be all real numbers. Again, we could write it exactly the same as we did here. The range would be all y values, so it would start at -infinity and would go all the way up until that point. So it would go from -infinity all the way to -2, and it would include that value. You could also write it as y is less than or equal to -2. Where is it increasing? So it looks like it is all of this. So from -infinity to -1. Or you could say all x values less than -1. and then it's decreasing all over here. So that would be from -1 to infinity, or x is greater than -1. Okay, and on your homework, you're going to have it like this, where I'll ask you to write down all of these things. So we'll do one more together. We'll say x-intercepts. Okay, here we have one x-intercept. It's at -1, 0. The y-intercept is right here. Let me zoom in a bit for you guys. So we'd have 0, 2. Axis of symmetry, that's the vertical line that cuts the parabola in half. So that would be x equals -1. The vertex looks like it is the same as the x-intercept, -1, 0. Is the vertex a maximum or a minimum? It's a minimum, and its value, this one's kind of tricky, is going to be 0. Okay, it's always going to be like the y value for your vertex, and your axis of symmetry will always be the x value for your vertex. Domain is all real numbers, and again, we could write it the other two ways. Range, so all y values would start at 0 and go all the way to infinity. Where is it increasing? So that's everything right of the vertex. So it would be -1 to infinity. Or we could say all x values greater than -1. Decreasing would be everything left of the vertex, or the axis of symmetry. And we'd say that would go from -infinity to -1, or all x values less than -1. And then direction of opening would be up. All right, well, if you have any questions, please let me know. There's also some great things that you could look up online too if you have more questions. All right, good luck.